All right, so today we're looking at one more formula for a geometric series, and that is, what if it's not infinite? What if you just want like the sum of the first 5 terms or the sum of the first 3 terms or so on? So take a look at each of these summation notations. Can you explain if it's a partial or infinite series that we're looking for, and how would you be able to explain your decision? Well, the key comes to looking at the top. Do you see an infinity sign at the top of your notation? Oops, my movie's off. All right, so look at the top. Are you going to connect? Okay, here. Look at the top. Do we want all the terms, or do we want just a certain amount of terms? So this is saying find the sum of the first 5 terms. This is saying find the sum of every term. So again, here's that formula we've spent 2 days looking at. If it's infinite, it's the first term over 1 minus the ratio. But there's a new formula for if it's not infinite. To find the sum of a partial geometric sequence, here is the formula. All right, so let's practice that. Let's find the sum of the first 5 terms of this. So here's how we write out. Sum of the first 5 terms equals the first term, still 0.3, times 1 minus the ratio to the n power. So here n is 5. We want the first 5 terms over 1 minus the ratio. Okay. So here's what we're going to add up. And we could just type this right into our calculator. So let me do that really quickly. So we have 0.3 times 1 minus 0.1 to the 5th power. Hit enter. Divide by minus 0.1 or 0.9. Okay, so this answer, the sum of the first 5 terms, is 1/3. Still 1/3. I think we got the same thing here. Okay, so that is the new formula that we're going to look at today, and this is what we're going to practice. So here's your strategy. Read the problem. First of all, determine is it arithmetic or geometric? Is it partial or infinite? And choose the appropriate formula and solve. So there's 3 formulas that we're going to use. Here are 2 of them, and then if it's arithmetic, you just have that one formula to use. Okay. So here's an example of using the partial sums formula. Evaluate the first 20 terms of this right here. So it's partial sums. Here's the formula. The sum of the first 20 terms equals the first term over 1 minus the ratio to the n power over 1 minus the ratio. So the sum of the first 20 would be the first term is 0.3. over 1 minus the ratio, which is 2, and then to the 20th power over 1 minus 2, and that's really messy. Okay, so you type that into your calculator, and it ends up being really big because notice we're doubling all these terms. So you have 0.3 and then you double it, and you get 0.6 and you double it. You get 1.2 and you double it, and you get 4.8 and you double it. And these get really big really fast, so if you add up the first 20 terms, it ends up being a big number. If you try this in your calculator, hit enter before you divide, it helps. You get 314,573. So there's the sum of the first 20 terms, 314,573. Let's do another example. You drop a tennis ball from a height of 60 centimeters. With each bounce, it rebounds to 50% of its previous height. Calculate the sum of the first 5 bounces. So again, I think with these rebound ones, it helps to draw the picture. So first it goes down 60 centimeters, and then it goes halfway up, but then it goes down again at 30 centimeters, and then it goes halfway down, but then up again, or up and then down, sorry, order is wrong. So then it goes down. Oh, I changed color here. And then it goes 15, and so on. So what is this, 7.5? Okay, and it just says for the first 5 bounces. Calculate the sum of the first 5 bounces. So I'm going to count this as a bounce. Should I not, though? Let's see. So this, I'll call this as my first term. Yeah, I'll include this as a bounce. I know it's not a bounce, but it does hit the ground. So first, second, third, fourth. So I need one more, up and down. And this is 3.75. Okay, so we could just add all these up. But if we want to use the formula, there's 2 ways to do this. We could add up this, and then we could multiply this by 2. Because it's an up and down, we can multiply by 2, and then add the 60. Or we could calculate with 2 different terms. We could do 60 as the first term and calculate that, all the downs. Okay, so here's the 2 methods. Method 1, find the sum of the first 5 terms with 60 as the first term, and then add that to the sum of the first 5 bounces, or first 4, the 4 left, with 30 as the first term. I'm going to do method 2 though. So method 2 is, let's ignore the 60. Let's figure out the sum of the first 4 bounces starting at 30 as the first term. And then we're going to add the 60 to that. Okay, so here's my work for that. So our formula, the sum of the first 4 bounces is the first term, we'll say it's 30, times 1 minus our ratio, which is 0.5, for the first 4 bounces, over 1 minus the ratio. Okay, so let's calculate that. And if I do that in my calculator, what do I get? 30 parentheses 1 minus 0.5 to the power of 4, hit enter, divide by 0.5, oops, 0.5. Okay, so I get 56.25. But that is just one of the values, so just like going up or going down. So now I'm going to multiply that by 2, so 56.25. We're going to multiply that by 2 to get the other up and down. But then we have to add the 60, so plus 60. So in doing all that work, multiply that by 2, add 60, here's our answer. 172.5 will be all of this, the down and then all the up and downs left over. Okay, let's do another example of just finding a term versus finding a sum. So u sub 10 means find the 10th term. So you could find the pattern and just keep hitting enter in your calculator. This is geometric. It looks like if we do 24 divided by 16, it looks like this ratio is 1.5. So this is multiplied by 1.5. All right, so to find the 10th term, here's our summation notation. N equals 1. We can find the 10th term. First term 16. This is going up by 1.5 to the n minus 1 power. Let's just use this part to find one term. It's just 16 times 1.5. 10 minus 1 is 9. So if we do that, this gives us the 10th term. So again, we have this is the first term, so the 10th term would be 10 minus 1. And that would be 15.09. Okay, so here's the 10th term, or you can just hit 16, hit enter, and then multiply by 1.5 9 more times to get to the 10th term. This says find the sum of the first 10 terms. It's a partial geometric sequence, so we say the sum of the first 10 terms is the first term times 1 minus the ratio, which is 0.5, to the 10th power over 1 minus the ratio. And if we do that, the sum of all these terms is going to be 1,813.28. Okay. Another example, find the sum of the first 12 terms given this recursive equation. Okay, so here's the summation notation. We want the 12 terms, first term 16. This is ratio 0.8 to the n minus 1 power. Let's use the formula, the sum of the first 12 terms, so I need an S here, equals the first term times 1 minus the ratio to the 12th power over 1 minus the ratio. So the sum of the first 12 terms, my calculator is 74.5. Okay. And then the last one, finding a missing value. We practiced this yesterday. Plug into the right formula, and then you're going to use algebra to solve. So this is sum of the first 15 terms is the first term over 1 minus the ratio to the 15th power over 1 minus the ratio. Plug in everything that you know. We know the sum is 1081.97. We don't know the first term. We have the ratio to the 15th power over 1 minus the ratio. All right, I'm going to change these to numbers. So we have 1081.97 equals u sub 1 times negative 154.568 over negative 0.4. All right, I'm going to get rid of this negative 0.4 by multiplying each side by negative 0.4. Okay, so I get, so this cancels. I get, and then dividing. So I get, I wrote it here, negative 432.788 equals u sub 1 times this negative 154.688. Running out of room. Oh, this is u sub 1, yep. Then I'm going to divide each side by this number, negative 154.688. So again, divide each side. So multiply, divide. We'll get our first term, which is about 2.8. Okay, so this one is just using the formula to work backwards and plug in. All right, so we will review all of these ideas, the main 3 formulas, arithmetic, infinite geometric, and partial geometric, and then we'll be taking a test on this.